So welcome to 9.3. So we're going to take powers and multiply them with each other. So 2 squared is 2 times 2, which must be 4. 2 cubed is 2 times 2 times 2, which is 8. So what is 2 squared plus times 2 cubed? Well, 2 squared times 2 cubed must be the same as 4 times 8, or 32. So what's 2 to the 5th? Well, that's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2. Interesting, that's also 32. So both of those had the same answer. 2 to the 5th, we just said, was 32, so this is 32 times 2, which is 64. And 2 to the 6th is one more than 2, one more multiplying by 2. I guess I'll write it out. Right? And so that's 32 times 2. It's also 64. So now notice there's a pattern here. 2 to the 5th times 2 to the 1st equals 2 to the 6th. 2 squared times 2 cubed equals 2 to the 5th. That's interesting. Well, look at this. This is true, by the way. X times x is x squared. Now let's remember there are ones here. X times x is x squared. And it turns out we should have known that already. And x cubed times x to the 4th is x to the 7th. Y times y times y is y cubed. There's little ones there. And y squared times y to the 5th equals y to the 7th. It doesn't matter what number x or y is. So what's the pattern here? Well, it turns out when you're multiplying powers, y squared is a power. It has a base and an exponent. Y to the 5th is a power. It has a base and an exponent. Same for the x cubed and x fourth. When you multiply powers, all you have to do is add the little exponents. 1 plus 1 is 2. X times x is x squared. Y times y times y. 1 plus 1 plus 1 is y cubed. More advanced, right? All you have to do is add the 3 and the 4. And you get x to the 7th. Now why is that? Because x cubed is x times x times x. X to the 4th is x times x times x times x. So if you multiply the two of them together, you get 7 x's being multiplied, x to the 7th. But there's this wonderful shortcut. Y squared times y to the 5th is y to the 7th. Now we're multiplying powers today. There's this adding the exponent shortcut, but we are multiplying powers. All right, so the base, the bottom, the x in this case, has to be the same. So it says simplify the expressions. You're not going to know what x is. You add the 2 and the 3, and that will equal x to the 5th for all values of x. So again, treat the 10, we're not evaluating this, we're simplifying it. Treat the 10 just like x. So we keep the 10. We don't do 100 or anything like that. And then it's to the 7th because there's a 1 there that's missing, right? So it's 2 plus 1 plus 4. That equals 10 to the 7th. Right? When we have fraction bases, we need parentheses around it, and that equals 1/3 to the 6th. You're adding the exponent. Now, remember, that's the rule for powers. But this problem, right, x cubed, that's a power. X to the 5th, that's a power. This 2 and the 7, those are coefficients, right? Those are numbers multiplying the powers. And when we multiply things like this, you actually multiply the coefficients. So 2 times 7 is 14. X cubed times x to the 5th. The power part, same rule, add the exponents. Now why is it 14x to the 8th? Because this is 2 times x times x times x. And this is 7 times x times x times x times x times x. So you multiply those two, right? You have 14 times x to the 8th. That's what you have. And notice I say x to the 8th. I don't say x to the 8th power because we're going to say this hundreds and hundreds of times. 14x to the 8th. All right, so what does that have to be? You multiply your coefficients, -5 times 3, -15. You add your exponents for the power. Y times y is y squared, and you say that is -15y squared. All right, so yeah, there's some ones there. Oh, there's a -1. So we have -6 times -1 times 1. That's 6 for our coefficient. And we have x squared times x to the 4th times x to the 1st. 6x to the 7th. Right? How do you find the area of a rectangle? Length times width. So this is 8x squared y times 7xy. So you would multiply 8 times 7, 56. You add the exponents to get x cubed, y times y, right? Y squared. So the area of this, right? X and y are some missing information. Will be 56 times x cubed, if we're ever told what x is, times y squared. Right, so you do the x's with the x's and the y's with the y's. You don't mix them together, is what these notes are trying to tell you. The coefficients are 4 and 2. 4 times 2 is 8. Then you do the x's times the x's and add the exponents. 2 plus 5 is 7. The y's times the y, you get y to the 9th, 3 plus 6. All right, so what are our coefficients are negative 8, 6, and 2. Well, 6 times 2, we can multiply coefficients in any order. Commutative property still applies. 6 times 2 is 12. 12 times negative 8, negative 96. All right, now let's look at the x's. We have x times x, so that's x squared. We have y squared times y, that's y cubed. We have a z now, z times z cubed, z to the 4th. So you'd say that is negative 96, x squared y cubed, z to the 4th. Practice saying that. All right, now, this is where we see if you understand what a coefficient is. These have very different answers. Simplify them both. Right, so this is 7 squared times 7. That's 7 cubed, right? You treat that 7 just like x, because that's the base of the powers, right? This is still a power. It's 7 to the first power, all right? Here the 7s are coefficients, right? So they actually get multiplied. And this is 49x cubed. The x is the base of the power. Okay, let's see that again. So these are very different. This is negative. Don't multiply. You treat that negative 5 just like it was x or y. Negative 5 to the 4th, right? There's a 1 there. Here, this is negative. These are coefficients again. Negative 5 times negative 5, 25. Y times y cubed, y to the 4th. All right, so it turns out that scientific notation uses the same rules. Compare the first problem here to this example, right? If you have 3 times x to the 4th times 2x to the 5th, you'd multiply the coefficients 3 times 2 and get the 6. You'd add the exponents of x to the 4th times x to the 5th and get x to the 9th. This is the same rule. If you have 3 times 10 to the 4th times, this is multiplication, right? Because if you don't see a symbol, it's always multiply. Times 2 times 10 to the 5th. So you multiply 3 times 2 and get 6. Then you add the exponents for the power. Now notice the fonts. That's my time symbol. That's what an x looks like. I always use the same fonts. So this is 6 times 10 to the 9th. You multiply that 3 times 2, just like your coefficients, and then you add the exponents for the power part. All right, so let's try this. All right, so we have 2.7 times 3, which is 8.1. And then we add the exponents of the two powers, and we get 10 to the 11th. 8 plus 3. So 3 times 10 to the 8th meters per second is the real speed of light. So if you have 3.8 times 10 to the 8th, and if light travel, that's meters for 1 second. That's what meters per second means. So if we multiply that by 2, we would get the distance, right, for 2 seconds. These seconds cancel out, and you would get the distance it travels in 2 seconds. And 3.8, I did that earlier. All right, 3 times 10 to the 8th. So 3 times 10 to the 8th is 2 times 3 is 6. So we'll go 6 times 10 to the 8th meters, right? That's meters in 2 seconds. 3 times 10 to the 8th meters in 1 second. All right, so negative exponents, right, follow the same rules. Rules are rules in math. That's what's great about math. You learn a rule, it's always going to be the rule. There might be a new situation for that rule, which you have to figure out, but a rule's a rule. So I said when you have powers with the same base, you could just add the exponents. So do that. Negative 5 plus 7 is x squared. All right, so same rule. 9 times 1 is 9. That's the coefficient. X to the negative 1, all right, so we get x to the 0, right? Because negative 1 plus 1 is 0. Y to the negative third times y to the fifth. Negative 3 plus 5 is 2. Right, that always becomes x to anything to the first power is 1, so that simplifies to 9y squared. Okay. Scientific notation, right? You can multiply a small number like 3. This is a small number, 3 times 10 to the negative fourth. That is a fraction times a big number. So we do 3 times 2.6, and I'm getting 7.8. And then you add the exponents, negative 4 times 10 to the 12th. Right, negative 4 plus 12 is 8. And that is 7.8 times 10 to the 8th. Now, why does this all work? Now, you could do this the long way, right? Negative exponents make reciprocals, right? You have 1, that's 1 over x to the 5th, right? And that is x to the 7th, right? So that is x on 7x's in the numerator. We're going to talk about this more in the next lesson. That is 5x's in the denominator. Being right, that's what x to the 5th is. That's what x to the 7th is, right? You could write it all out that way, but we have this nifty shortcut. When you multiply powers, add the exponents. Okay, so we're going to practice this one. If I can get this to do what I want. So there they are, but you should do all of those. And my pen all of a sudden is acting up. See if I can get it to work. There we go. All right, so the first one is negative 6. You keep the negative 6 just like it's x or y. And then you add the exponents, and that's equal to negative 6 to the 9th. Don't start multiplying negative 6's. That will drive you crazy. All right, there's a negative 1 coefficient there. That's a little tricky. So negative 1 times 1, negative 1. Now, I'll actually write it. Then x times x. Add the two exponents, x squared. Y times y to the 5th. There's a 1 there. Y to the 6th. Right? We never write negative 1 coefficient. So this is negative x squared y to the 6th. That is the answer. Right? Parentheses around fraction bases. 8 plus negative 6, 2. That's 1/7 squared. Again, negative 9s are coefficients, right? So they actually get multiplied. Negative 9 times negative 9, positive 81. X cubed times x, x to the 4th. 81, x to the 4th. Coefficients, 4 times 12, 48. X to the 9th times x to the negative 7th. 9 plus negative 7, 2, x squared. Y to the negative 2nd times y cubed, y to the 1st. We're not going to write y to the 1st. We're going to write y. 48 x squared y. Scientific notation, same rules, right? 1.49 or 1 49/100ths, and 5 work just like coefficients. And 4 times 5 is 20, 24, and move the decimal twice, so we get 7.45 times 10, 6 plus negative 4, 2. 7.45 times 10 to the negative 2nd. I tend to not say squared or cubed when we're doing scientific notation. That's the one exception to that. All right. All right, so what does this question mark have to be right there? The truth is you don't have to look at anything other than y. Just ignore everything other than y is the trick to these, right? Y question mark times y squared equals y to the 7th. Whoop, wow, I'm thinking about the answer, right? The question mark has to be 5, right? All the rest is done for you. Let's just see that. 4 times negative 7 is negative 28. X squared times x to the first is x cubed. So the missing number there, you just have to work backwards and do blank, right? Blank plus 2 equals 7, right? Good luck with the homework.